Hello, welcome back. Today we are going to be going over Python and data structures. Let's begin by looking at binary search. We first need to create some data for our inventory. Let's set up an array of different toppings and print them to the screen. We will use binary search to see if a topping is in stock in our toppings list, which is a sorted list of strings, alphabetical order. Binary search requires sorted data to work correctly. Let's now define the recursive binary search function search toppings. The function name is called search toppings and searches for a topping. Let's now go over the parameters. Data. The list to search. Here, toppings. Target, the topping you're looking for, e.g., mushrooms. Low, the starting index of the current search range. High, the ending index exclusive of the current search range. Binary search doesn't examine the entire list. Instead, it repeatedly narrows the search range, cutting the remaining portion in half each time. The recursion stops when the range has shrunk to either one element or none at all. This is the base case. When the condition high minus low is less than or equal to 1, it becomes true. It means the search window is as small as it can get. Either the range is empty, low equals high, or it contains exactly one element, high equals low plus 1. At that point, the algorithm simply checks whether the single remaining element matches the target. If it does, it returns that index. If not, it returns none, indicating that the target isn't present. During each recursive step, the algorithm computes a midpoint index. Integer division ensures this midpoint is always a whole number. For example, if the current range is from index 0 to index 9, the midpoint is 0 plus 9 /2 equals 4. Binary search works by comparing the target value to the element at this midpoint. This is the divide and conquer moment. If the target is alphabetically less than the middle element, it must lie in the left half of the current range, so the algorithm recurses into that half. Otherwise, the target must be in the right half, including the midpoint itself, so the recursion continues there. Each recursive call reduces the search interval until the base case is reached. In this example, the target is a pizza topping, specifically mushrooms. The initial call sets the search range to cover the entire list of toppings, from index 0 up to index 9. The search proceeds step by step. In the first call, the midpoint is index 4, which contains jalapenos. Since mushrooms comes after jalapenos alphabetically, the algorithm moves to the right half. In the second call, the range is now from index 4 to 9, and the midpoint is index 6, containing, quote, pepperoni. This time, mushrooms comes before pepperoni, so the search shifts to the left half. The third call examines the range from index 4 to 6. The midpoint is index 5, which holds mushrooms. Because the target is equal to the midpoint element, the algorithm again moves to the right half, which now contains only one element. This triggers the base case. The single element at index 5 matches the target, so the algorithm returns 5. That result then propagates back through all previous recursive calls.